Hi, my name is Darian Hirotsu, and welcome to our NEC SDN Technical Deep Dive series. In this video, we'll cover how to implement service chaining using NEC's programmable flow technology. As service provider and cloud operators, we're on the lookout for new ways to introduce services and products to better leverage our existing infrastructure investments. This video is for technologists looking to implement service chaining to introduce dynamically new networking services. To illustrate service chaining using NEC's SDN programmable flow solution, we'll cover the following 4 steps. We'll start with an overview of service chaining by providing some definitions as well as introducing relevant technologies such as NFV or Network Functions Virtualization. Next, we'll cover how service chaining is useful by showing how to use service chaining to introduce IT agility into your organization. Next, we'll show you a sample VTN or virtual tenant network configuration to introduce how to deploy service chaining via service insertion on NEC's programmable flow controller. We'll conclude the video with a demo of service chaining using programmable flow with other third-party network functions. Now, to provide an overview of service chaining, we'll start by covering some basic terminology and concepts. First, NFV, or Network Functions Virtualization. Now, this is a framework to deploy and manage virtualized network functions. Now, recall that typically a network function such as Layer 7 firewall or load balancing would run on some sort of dedicated single-purpose physical appliance. With NFV and the NFV framework enables additional flexibility by providing the means to deploy and manage these network functions as virtual instead of physical appliances on x86 servers rather than dedicated single-purpose boxes. Now, changing the topic a bit, while NFV is a very powerful concept on its own, it further benefits from service chaining. So service chaining enables the dynamic chaining of either virtual or even physical network functions into the path of traffic. So traditionally, when trying to introduce a physical network function, it would require substantial planning of configuration, as well as potential downtime to introduce the new network function into the path for traffic. And also, as new services are turned up over the infrastructure, traditionally network configurations will need to be deployed on a box-by-box basis, which can be a slow process as well as error-prone. So service chaining enables better IT agility by allowing users to dynamically introduce new virtual or physical network functions into the path of traffic via a centralized location, regardless of any underlying physical topology. Now, just to give you an idea of how this works, with NEC and programmable flow, we can deploy service chaining using service insertion in a virtual tenant network, or VTN, using flow filters to redirect traffic as needed to the proper virtual or even physical network function. Now, in the next slide, we'll cover some of the additional details of how this works and an illustration of service chaining with NEC's programmable flow. Here we'll show you some of the additional details of how to achieve IT agility using service chaining. As a background, this is based on NEC's virtual tenant network, or VTN technology, which is a network virtualization technology that enables multi-tenancy. Now, with programmable flow, service insertion and the building of service chains is achieved on demand via either centralized CLI, via GUI, or a series of web API calls, which is NEC's term for a REST API. Also, users have granular control over which flows get redirected to specific services or network functions. This is all controlled by policy, or what NEC calls flow filters. Now, to visualize how service chaining works, here we're showing a topology of a physical network at the bottom of the slide and the virtual networks that are deployed on the physical infrastructure. So this physical network consists of a series of servers, which may be running virtual machines, as well as an open flow fabric, shown there in blue. We also have a mix of both physical and virtual network functions, including WAN optimization, DDoS prevention, Layer 7 firewalling, and load balancing, or also known as application delivery control. So this physical network could be some sort of public cloud provider, it could be a service provider providing infrastructure as a service, as well as the value-added network functions provided by those appliances that we just mentioned. Now, moving up to the virtual network view, here we have 2 tenants, customer A in red, and then customer B in green. So suppose here that customer A is leveraging server A and server B, while customer B is leveraging server C and server D. So getting to IT agility, we can introduce specific network functions for different customers as needed. So to show this, suppose customer A wants to introduce WAN optimization, firewall, and load balancing services in the path of traffic between server A and server B. So using programmable flow, we can deploy flow filters to introduce these network functions into the path for traffic. Now similarly, suppose somewhere down the road, customer B wants to introduce DDoS and firewall. Again, using flow filters, we can build the required service chain to stitch only the desired flows into the path of traffic. These changes can again be achieved on demand via centralized control from the CLI, the GUI, or via a series of web API calls from some sort of orchestration system. So next, we'll show the required configuration on the PFC to deploy service chaining in this fashion. Here, we're illustrating a partial VTN configuration from a programmable flow controller without any network functions introduced into the path of traffic. So recall from the previous slide, we had a DDoS appliance to provide the DDoS prevention network function. In this VTN configuration, note in the upper right, we have two vexternals called rdint and rdext. rdint is the configuration to send and receive traffic to and from the internal interface of the DDoS appliance. rdext is to send and receive traffic from the external interface of that same DDoS box. In this slide, no policy or flow filters are deployed, meaning no services have been inserted. So traffic is simply flowing between client and server, and in the next slide, we'll show you how to introduce the proper configuration change to introduce the DDoS network function into the path of traffic to build a service chain. Now we've deployed the required configuration change to introduce the DDoS appliance into the service chain. Now just as a reminder, this configuration may be centrally deployed on the programmable flow controller via CLI, via GUI, or by a series of web API calls from something like an orchestration system. So with this configuration in place, just to walk you through how the configuration works, traffic first comes from clients and enters the VTN via a vBridge called VBR0011, shown in the upper left. After entering the VTN, traffic is routed to a different subnet by a vRouter in this configuration called VRT. On the egress interface of the vRouter, we have a policy or flow filter applied that redirects all IPv4 traffic to the external interface of the DDoS appliance, which is identified in the configuration as rdext. With this policy in place, all IPv4 traffic from customer clients is sent to the DDoS network function. Now similarly, return traffic from the DDoS appliance re-enters the VTN via the rdint configuration in the upper right. There we see also a flow filter applied that redirects all IPv4 traffic back to a vBridge called VBR0021 in the upper left. This allows traffic to be forwarded to an end server, thus completing the service chain. Next, we'll show you the result of this configuration by showing a demo of service chaining using programmable flow and various other third-party network functions. In this demo, we're illustrating service chaining using NEC's programmable flow solution. On the right, we have a spine leaf OpenFlow fabric consisting of OpenFlow switches and a programmable flow SDN controller. In the upper left, we have a ping test running to generate traffic to a virtual machine. Notice we can visualize the flows over the physical network using the PFC's web GUI. Also, traffic is flowing directly from client to server, and no network functions have been stitched into the service chain. Now we'll switch views to illustrate the virtual network. Notice we have a pool of network functions consisting of a Radware DDoS appliance, a Palo Alto virtual firewall, a Riverbed WAN optimizer, and an F5 load balancer. In the bottom left, we have a terminal open to the PFC. We shall run scripts to introduce network functions into the service chain. In this first demo, we shall introduce the Palo Alto firewall and the F5 load balancer. Once the configuration has been applied, notice in the right, both network functions are now in the service chain. In the next part of the demo, we shall remove the F5 load balancer to illustrate we can both add and remove services on demand as required. After reviewing the flows in the web GUI, we now see that the F5 load balancer is no longer in the path of traffic. To finish the demo, we shall add all network functions into the service chain. In this demo, although only ingress traffic traverses the various network functions, we can easily use scripts to redirect return traffic to the network functions as well. This illustrates we have granular control over what traffic we can redirect to the various network functions. After reviewing the flows and the web GUI, we see all network functions reside in the path of traffic. This now concludes the demo of service chaining using NEC's programmable flow. In this video, we illustrated service chaining using NEC's programmable flow solution in 4 sections. We provided an overview of service chaining, as well as other relevant technologies such as network functions virtualization. We then illustrated the benefits of service chaining, showing how to introduce IT agility using this technology. We then covered a sample VTN configuration to show how to deploy service chaining on NEC's SDN programmable flow controller. We concluded with a demo of service chaining using programmable flow and other third-party network functions. In this video, we covered how to implement service chaining using NEC's programmable flow technology. To learn more, consult NEC's documentation to learn about their web API for network orchestration, and download the virtual PFC from NEC's website to get hands-on experience with this technology. We look forward to seeing you in the next video.